our recording now. So let's continue our discussion. And in this case, we are looking at assigning the stereochemistry of an alkene as Z or E. So just as a refresher, if your groups are on the same side, if your high priority groups are on the same side of the alkene, then it would be considered Z. If they're on opposite sides, we have an E alkene. So just as a refresher for our priority assignments, we rank each group on each side of the alkene in order of highest to lowest priority. If the highest priority groups are on the same side of our alkene, then it would be considered Z. If they're on opposite sides of the alkene, they would be considered E. So let's try the following example. Let's spend about 2 to 3 minutes on this example, and I'd like to see some responses in the chat for the proposed assignment for this structure. For those who are with us during this synchronous session, don't be shy to share your responses in the chat or verbally. And for students who are watching this asynchronously, make sure for at least two to three of the problems that you work on during this recorded session that you write down your logic and proposed solution, and you can send it to me and I'll be able to provide you a small amount of participation extra credit. For those in class, I'd like to see your responses verbally and in the chat. Or if you have a question, asking a question is a perfectly viable way of contributing to this discussion. You can also use the annotate tool to share your responses on the class whiteboard. So let's start this discussion. Let's spend about 3 to 4 minutes on this problem, and let's assign this alkene as Z or E. So let's see some assignments and, beyond just the assignment, some justification. So why do you say it's Z or E? And if you have any questions, I'd be happy to address them. So we see that Anna has proposed the following ranking arrangement, and as our highest priority substituents are on opposite sides, we have this center assigned, this alkene assigned as E. We also see in the chat that multiple other students have proposed that this alkene is E. I want to give students another minute. Does anyone else have a proposed assignment for this alkene? Do you agree with the assignment of E? Do you disagree? Let's try to get a few more responses in the chat, and then we'll discuss this example in about another minute. So does everyone agree that the center looks like an E alkene? Does anyone have an alternative proposal? Is there any questions that you have on this assignment? Okay, so let's discuss. So the responses in the chat seemed reasonable to me. In terms of priority counting, we see that this isopropyl group is priority number 1 because there are 3 carbons attached to our first center compared to 2 carbons and 2 hydrogens. Hydrogen, of course, is lower priority. So in turn, on the right-hand side, we have the following priority assignment. Putting a box around our highest priority groups, we see our highest priority groups are on the opposite side. Ergo, this would be an E alkene. Does this example make sense to everyone? Does this example make sense? Perfect, perfect. So let's keep working on a few more examples. Let's look and let's try to assign the configuration of the following alkene. Just like before, I'll give everyone about 3 to 4 minutes to work through this problem. I'd like you to assign this alkene as E or Z. And again, don't hesitate to share your responses in the chat or verbally for the proposed assignment of this alkene. Additionally, you can also ask a question, and really don't be shy to share your proposed responses. You can even share your proposed responses as a private message to me, and I can verbalize your responses in front of the class if needed. So really don't be shy. There are many means of participating, and don't be shy to use the annotate feature as well as all of these features allow you to participate both anonymously and non-anonymously. So let's keep working on this example, and I want to give everyone the proper 2 to 3 minutes so that way they can draw their conclusions. Don't be shy as well to use the annotate tool to add priority assignments to this drawing on our class whiteboard. So we see a few responses in the chat, and we even have a student sharing their annotations. Perfect, perfect. This will be very useful getting used to the annotate tool when we move on to mechanisms. So I really encourage you to attempt and try using the annotate tool during these problem solving sessions. So to help with that, looking at the placement drawn by one of our students, does everyone agree with these priority assignments? Does everyone disagree with these assignments? What does everyone think for these priority assignments? Does that look reasonable to everyone? Perfect, perfect. So just to allow other students to potentially share their perspective, I'm going to give everyone about another 30 seconds to a minute. And if there are any questions or any other responses that you have that I can provide feedback on, I'd be happy to do so. Just want to make sure everyone has enough time to share their responses. Okay, so let's take a look at this example. It's great that we're seeing more activity in this class discussion and that we're seeing more students both sharing their perspective and sort of playing off of other students' responses. This dialogue is really beneficial in sort of breaking down more difficult problems in organic chemistry. So let's look at the following example. So first, in terms of priority, chlorine is our highest priority. If we compare these two carbons, this carbon has an oxygen and a carbon attached to it, compared to 3 carbons. Oxygen wins out in terms of atomic mass. So this methylene group with the ether attached is priority 1, while this alkane is priority 2. We then put a box around our highest priority groups, and these two substituents, because they're on the same side of the alkene, would be assigned as Z. Does that make sense to everyone? Does that idea make sense? Is everyone feeling a little bit more comfortable with these priority group assignments? Any questions before we look at another example? So in these next examples, you're going to want to be really careful with your priority assignments. So I'd like, just like I've drawn here, these priority lists that we use to rank groups in order of priority, in order of the highest atomic mass substituents. You're going to want to be familiar using these to solve later problems. So let's take a look at this following example. This one is not too bad. Let's give everyone this time about 2 to 3 minutes, and I'd like you to assign the configuration at the following alkene. And if there's any part that you have a question about, don't be shy to ask a question verbally or in the chat, and don't be shy to share your proposed responses. So we already have one of our students sharing their priority group assignments, their priority numbering, and the alkene configuration. We also have other students who are thinking that this structure looks like a Z alkene. Let's try to get a few more responses in the chat, and then we'll discuss in about another minute to a minute and a half. One other thing that I would like is, especially for these problems where the priority assignments are so critical, don't be shy as well to try and utilize the annotate tool to share, just like we've seen over here, the proposed priority group assignments. Really developing comfort with using these annotate tools and other structure drawing tools available as part of our Zoom meeting will be invaluable when we start to talk about mechanisms. So we see a lot of students proposing that the structure is Z. And we even have some follow-up priority assignments. That's wonderful to see. What does the rest of the class think? Does everyone agree that it's a Z stereocenter? Does everyone disagree? What does everyone think? So we see a pretty consistent consensus that our alkene, which is right here, we have a pretty consistent consensus that this alkene is Z. So let's check our work. Thank you all for sharing your responses. I find often it's more comforting to share your response in the context of the class. When everyone else is drawing on the whiteboard, it makes it a little bit, I notice that it's often easier for students to contribute. So it's wonderful to see this class discussion. So our chlorine is priority 1. This alkane is priority 2. The methyl is priority 1. The hydrogen's priority 2. Boxing in our highest priority substituents. They're on the same side, ergo this alkene would be Z. Does that make sense to everyone? Is everyone comfortable with this example? Any questions before we move on? Okay, so this has been a wonderful problem-solving session. So we've wrapped up and we've completed chapter 5. I wanted to try out this discussion prompt and try out this participation incentive for this lab, and we'll be continuing this participation incentive for all of our future lecture sessions. So we've finished up and we've wrapped up chapter 5.